Hi, it's Eldnar Nivek again, and I teach maths. This is lesson 2. We're looking at the OCR spec of A-level maths. The first section is on Surds. So it's Core 1. This is lesson 2 on the very exciting Rationalise the denominator. So, let's just refresh what we did in lesson 1. You saw my lesson 1. It was on the rules of surds. So we'll just have a quick refresh to make sure we know what the rules are. First of all, we've got, straightforward, if we've got root of a number that can be expressed as x times y, then we can express that root x times root y. And that's a very useful little rule when handling surds. The other one is if we've got a number which we can express as root x over y, then we can express it as root x divided by root y. And we covered that in lesson 1, but we'll be using it in lesson 2. So this lesson is about rationalising the denominator. But why do we need to do that? Well, what's it all about? Why do we need to rationalise the denominator? Well, let's just try and calculate this. If I said try and calculate 1 over root 2. Now you might know that root 2 is approximately equal to 1. Yeah? Root 2 is approximately 1.414. Yeah, we say approximately equal to 1.414 because it is an irrational number, so it's 1.1414 going on forever and not repeating. So then we try and do the sum, we try and divide 1 by root 2. You don't divide 1 by 1.414, it's a bit tricky, but it's very tricky. However, we know root 2 it's not a rational number, it's an irrational number. That means it doesn't repeat, the decimal part doesn't repeat, and it doesn't end. So to make the denominator a rational number, a number that we can handle easily, there's a little trick that we do. So to make the denominator a rational number, we actually multiply it by itself. So we multiply root 2 by root 2. But if we multiply the denominator by root 2, we've also got to multiply the numerator by root 2. So we multiply the denominator by root 2, just 2, that's nice, and then multiply the top by root 2 as well. So we haven't changed the number, we've multiplied by 1. And that equals 1 times root 2 is root 2. Root 2 times root 2 is 2. So we get root 2 over 2, which is 1.414 divided by 2, which we can then do quite easily. We get 0.707. So we have a tick for that. So it's just a method of what we're doing is we're making the denominator into a whole number integer that we can divide quite easily. So we can say then that a over root b can be rationalised by multiplying the top and bottom by root b. So multiply by root b over root b, and that will give us a times root b is a root b, and root b times root b is b. So that gives us a root b over b. So we've rationalised the denominator. So what we do is, it's straightforward. If you've got a surd in the denominator, we multiply top and bottom by that surd. So for example, we've got 1 over root 3 equals multiplied by root 3 over root 3, and that will give us root 3 over root 3 times root 3, which is 3, root 3 over 3. Just a few more examples. you'll get these examples on the exam paper. I know now they seem dead straightforward and easy because we've been through it, but you will get them on the exam paper, that's without doubt. So let's have a look. We've got 4 over root 2. So we multiply it by root 2 over root 2. And that gives us 4 root 2, 4 times root 2, over 2, which is root 2 times root 2, which is 2 root 2, because of 4 and 2 cancels, gives 2 root 2. Another example. You should be really confident with these, because you know you're going to get them, you know they're going to turn up. 12 over root 3, multiplied by, what do we multiply by? Root 3 over root 3. And that gives us 12 root 3 divided by 3, which comes out at 4 root 3. Another one. A little bit more interesting because we've got a root on the top as well. Root 6 over root 2. And one way we can do it is what we've been doing, multiply by root 2 over root 2, which gives us 6 root 2. Root 6 times root 2 is root 12. So it's root 12 over 2. Can simplify that. Root 12 is root 4 times 3, so that's 2 root 3 over 2, which gives us root 3. It's a much easier way than going all the way through that. What we can say, or we can say root 6 over root 2 equals root 6 over 2 from the second rule that we looked at right at the beginning. Equals root 6 over 2, which equals root 3. That's a much simpler way of doing that. Another example, 7 root 2 over 2 root 3. We're going to multiply top and bottom by root 3. We don't need to multiply by the 2, we'll just leave the number as it is. We'll just multiply by the root 3. So multiply by root 3 over root 3. And that gives us 7 times root 2 times root 3 is 7 root 6 over 2 times root 3 times root 3 is 6, plus root 3 times root 3 is 3 times 2 is 6, so the answer is 7 root 6 over 6. There's a few examples here for you to try yourself if you want to pause it and have a go at these yourself. These are taken from exam papers or exam type questions, so it's the type of thing that you're going to get. Don't forget, what you're doing is you're generally multiplying top and bottom by the surd part of the denominator. So we've got 3 root 5 over root 3, we've got 4 root 6 over root 5. You could just ask yourself, what am I going to multiply it by in each of these examples? And you should find that you're very, very confident with this type of example. If you were to look through the past papers for OCR or AQA, you see this type of question turn up again and 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 again. So if you like to try those, okay. So now we're going to have a look at a slightly more interesting way of rationalising a denominator. So a question that often comes up is something like this. If you've got a question like rationalise, and the denominator is a constant plus a surd. Right. So in this case it's 2 plus root 3. So in this case it's 2 plus root 3. What we do is a little trick. We multiply top and bottom by what we call the conjugate of the denominator. So if the bottom is 2 plus root 3, the denominator, we multiply it top and bottom by 2 minus root 3. Okay? So if you've got 2 plus root 3, we multiply the top and bottom by what we call the conjugate, Yeah, and the conjugate of 2 plus root 3 is 2 minus root 3. You'll see how this works. It sounds a bit convoluted, but you'll see how it works in a second. So, we've got 2 over 2 plus root 3. We multiply the top and bottom by 2 minus root 3. 2 minus root 3. So multiplying the top out, the numerator, but 2 times 2 minus root 3 over 2 plus root 3 times 2 minus root 3. And that gives us, looking at the top, 2 times 2 is 4, 2 times minus root 3 is minus 2 root 3. So the top straightforward, 4 minus 2 root 3. The bottom, different ways of doing this, I prefer to. 2 times 2 is 4, there, and 2 times minus root 3 is minus 2 root 3. So we multiply the second bracket by the first bit of the first bracket. Same as the second bit of the first bracket. Root 3 times 2 is plus 2 root 3. And root 3 times minus root 3 is minus 3. Then we collect the terms up at the bottom. Okay. So we've got 4 minus 2 root 3 at the top, and collect the terms up at the bottom. Let's do the root 3's first. We've got minus 2 root 3 and plus 2 root 3. So they disappear. Minus 2 root 3 plus 2 root 3 is nothing. And 4 minus 3 is 1. So the answer is 4 minus 2 root 3. Isn't that nice? The nice bit is the minus 2 root 3 and the plus 2 root 3 disappear. We'll see that's going to happen again and again and again. Now this is something called, why that happens, something called difference of two squares. If you get a minus b times a plus b, just work it out, that will give us a squared plus ab minus ab plus b squared. Yeah. So the plus ab and the minus ab disappear, so we've got a squared minus b squared. And that's what we call a difference of two squares. So a squared minus b squared can always be expressed as a minus b, a plus b. And we'll see why that comes into this rationalising of the denominator a bit more later. If you look at the example we've just done 2 plus root 3 times 2 minus root 3, 2 squares. Example, another example. Let's say we've got 1 over 3 minus root 5. What we're going to multiply that by? The conjugate of 3 minus root 5 is 3 plus root 5. So we multiply the top and the bottom by 3 plus root 5. So we multiply the top out first, and we've got 1 times 3 plus root 5, which is 3 plus root 5. And the bottom, we've got 3 minus root 5 times 3 plus root 5. Now that's the difference of two squares, you see. So we can say 3 times 3 is 9, root 5 times root 5 is 5, so the bottom is 9 minus 5. That's what we just done last page. So it's 4. So the answer is 3 plus root 5 over 4. Hope you can see how we got that. 3 times 3 is 9, root 5 times root 5 is 5, and 9 minus 5 is 4. This one, got 2 over root 5 minus 2. So what we're going to multiply the top and bottom by? Well, the conjugate of root 5 minus 2, which is root 5 plus 2, times root 5 plus 2. Multiply the top out, and we get 2 root 5 plus 4. 2 times root 5 is 2 root 5, 2 times 2 is 4. The bottom, root 5 times root 5 is 5, minus 2 times plus 2 is 4, so we've got 5 minus 4, which is 1. So the answer, 2 root 5 plus 4. Now look at some exam questions. These are taken direct from fairly recent OCR or AQA A-level papers. You get 4 root 6 divided by root 5. It's one of the earlier examples that we looked at. Multiply top and bottom by what? Root 5. Yep. So multiply the top out, you've got 4, root 6 times root 5 gives us root 30, divided by root 5 times root 5 is 5. So we've got 4 root 30 over 5. That's the answer to that one. Next exam question, 14 over root 7. What we're going to do, multiply top and bottom by root 7. So there we've got 14 root 7 divided by root 7 times root 7 is 7. Rationalise the denominator. And we've got 14 over 7 is 2. So we get 2 root 7. So that's the answer to that, is 2 root 7. So we'll have a tick for that, a tick for that. And we'll go on to question 3. We've got root 2 minus 1 over root 2 plus 1. Don't let that throw you, we just multiply top and bottom by the conjugate, which is root 2 minus 1. So multiply top and bottom by root 2 minus 1. So we've got root 2 minus 1 at the bottom. I'm not able to predict what's going to happen on the bottom here. So multiply the top out, we've got 2, root 2 times root 2 is 2, minus root 2, minus root 2 again, and minus 1 times 1 is plus 1. So we just multiply the top 2 brackets out, then the bottom one, difference of 2 squared, root 2 times root 2 is 2, 1 times 1 is 1, 2 minus 1 is 1. That's straightforward. Collect the whole numbers first. 2 plus 1 is 3. Root 2 minus root 2 is minus 2 root 2. So the answer is 3 minus 2 root 2. Question 4. So these are exam questions. Don't get much harder than this. 1 plus 2 root 2 over 4 minus root 2. We multiply by the conjugate, which is 4 plus root 2. Top and bottom times 4 plus root 2. And multiply the top out. People have different ways of multiplying brackets, but doesn't matter which way you do it as long as you get the correct answer. So we've got 1 plus 2 root 2 times 4 plus root 2, which we'll multiply out shortly, and that is over 4 times 4 is 16, and root 2 times root 2 is 2. But we'll write it down longhand first. 1 times 4 is 4. 1 times root 2 is plus root 2. 2 root 2 times 4 there gives us 8 root 2, and 2 root 2 times root 2. Root 2 times root 2 is 2 times 2 is 4, so that should give us 4, shouldn't it? It should give us plus 4. So that's the top sorted. The bottom, we can do a difference of 2 squares as I did just a moment ago. 4 times 4, 16. Root 2 times root 2 is 2. 16 minus 2 is 14. So correct terms, we've got 4 plus 4 is 8. 4 plus 4 is 8. Root 2 plus 8 root 2 is 9 root 2. Over 16 minus 2, which is 14. And I'll leave the answer like that. So that's 8 plus 9 root 2 over 14. Example 5. We've got 3 minus root 3 over 2 minus root 3. So we multiply top and bottom by 2 plus root 3, that's the conjugate of 2 minus root 3. And so top and bottom by 2 plus root 3. So at the top we've got 3 minus root 3 multiplied by 2 plus root 3. 3 times 2 is 6 plus 3 root 3. Then we've got minus root 3 times 2. This is minus 2 root 3. And minus root 3 times root 3, which is minus 3. Divide that by 2 times 2 is 4, root 3 times root 3 is 3, 4 minus 3 is 1. So, correct terms up at the top. We've got 6 minus 3 is 3. We've got plus 3 root 3 minus 2 root 3, which is plus root 3. So we've got 3 plus root 3 over 1, which is obviously 3 plus root 3. And that's the answer. So I'm quite happy with those. They're exam questions. As long as you remember to multiply top and bottom by the conjugate of the denominator, that's the bottom, then you'll be fine with those. And that completes, that's lesson 2 on Surds. That completes Surds for Core 1 for the OCR and the AQA level course. Just to recap on that last bit, because this is the bit that will come up. If you've got 1 over a plus root b, then you multiply it by a minus root b over a minus root b. I've said 1, it doesn't matter what you've got on the top, you multiply by the conjugate of the bottom. And if you've got 1 over a minus root b, Then you multiply top and bottom by the conjugate of a minus root b, which is a plus root b. So it's a plus root b times a plus root b over a plus root b. And get that. So that's the way to handle that type of surd calculation. And so that completes the Core 1 section on surds. The next thing we'll be looking at is quadratics. So if you look out for lesson 3, that will be going up shortly. That's on quadratics. Very exciting, very interesting. So thanks for watching. Hope you enjoyed that. I hope it's sorted out your surds for your A-level course. And we hope to see you again.